problem 10, we are going to get to practice graphing every type of trig function we've seen. We'll start with sine and cosine. We also are going to have some h and k values thrown in as well. So part A, we've got y equals sine x minus pi, and inside parentheses, and then plus 3 outside. So a couple things to identify. First of all, we're going to have an h value of pi, so that's going to shift it pi to the right, and we're going to have a k value of 3. So we're going to go from 0 to 2 pi, so we'll get our theta axis set up here with our normal intervals. And next we will start to look at our y-axis. So if we have a k value of 3, that means it shifts up 3. So I'm going to make this a 1. This is 2. This will be 3. And then this will be 4 up here. So that x-axis that we are normally graphing our sine on now shifts up 3 units up. So this is kind of now our new x-axis that we're going to base this periodic function off of. Other things about the sine function, the a value is 1. So it's going to rise up 1, go down 1. And you do not have a b value, so your period is still going to be 2 pi. So your b value is 1. All right, now we can head to start graphing. So sine function is going to start at 0. It's going to rise up to its highest point, go back to 0, and then go down to its lowest point. But we had a phase shift right here going pi to the right. So that means each of these points are going to go pi to the right, pi to the right, pi to the right. So all those are going to be shifted over. This one would go to here. So all those get shifted over. So we have to start thinking about, we usually start right here. Now this point gets shifted over to the right. So we are going to start at pi and start to graph our sine function. So let's take a look at that. So our first position, pi. Then at that next position, it's going to go up to its highest point and then back down to 0. Now if I follow this curve, then it's going to go down to its lowest point and then back to 0. So that sine x minus pi is going to shift you to the right pi, and it shifts us up 3. Heading on to part 2, we've got a cosine x plus pi over 2. There's no k value, so this just shifts us. H is going to be a negative pi over 2, so it's shifting us to the left, pi over 2. So we'll get our graph set up again. Got our 2 pi, pi, pi over 2, and 3 pi over 2. Okay, cosine of amplitude is 1 here, so we're going to go 1 to negative 1, and the b value is 1, so that means we're going to have 1 cycle from 0 to 2 pi. All right, now we can start to graph it. So this time cosine would start here, and this is just the parent function. Here goes down to its minimum, comes back up, and then finishes up here. But we're going to go to the left pi over 2, so that means this shifts pi over 2, this one shifts pi over 2, this one shifts pi over 2, and this one shifts pi over 2. So they're all going to shift pi over 2 to the left. So let's take a look at what that would look like. I like to start with the 2 pi point. So the 2 pi point would have been right here. Well, it shifts pi over 2 to the left, so now it's going to be right here. And then at pi, we're going to be at 0. At pi over 2, we're going to be at negative 1. And then we're going to be right here. And if I kind of follow that curve, if I keep following, we're going to have our last point is going to be at 2 pi. So you start to notice these last two graphs, when you shift pi to the right, really what you're doing is making a negative sine graph. When you shift a cosine function, pi over 2 to the left, you are making another negative sine function. Those are called trig identities, so they're just changing to a different function. All right, we'll finish up with C. So tangent 1/2 t, and t is just going to represent theta. So that means that our A is going to be 1, and our B is going to be 1/2, which makes our period pi over 1/2, which is going to be 2 pi. And lastly, that makes our asymptotes equal to pi plus 2 pi n. So every period will have another asymptote happening. So pi is going to be where my asymptotes are. And we're graphing from 0 to 2 pi. So I'll graph, here's where 2 pi would be. Here's where pi is. Pi over 2. And 3 pi over 2. So I have an asymptote at pi. I'm going to make it green so it sticks out. Okay, and then our period is 2 pi. So the next asymptote wouldn't be till over here at 3 pi. We don't have enough because we're only graphing from 0 to 2 pi on the theta axis. So we don't have enough to get to that asymptote. So we're just going to graph the curve now between there. And tangent always going to start at 0. And then at pi over 2, we're going to reach where our amplitude is. And our amplitude is 1. So at pi over 2, we're going to be at 1. That's going to be that 45-degree angle on your unit circle. And then we can just graph that curve. Okay, next one, we're going to be at 2 pi because one period from 0 to 2 pi. There's my period. Okay, and I'm not going to go anywhere more to the right. So here we're going to graph this point. We can only graph the curve heading down that direction. So there would be our tangent function. This would, yes, eventually head off here and get to that asymptote of 3 pi over here, but we're only graphing from 0 to 2 pi, so I don't have to graph that side of the curve. So there would be our tangent 1/2. Back down to D, 2 cosine theta, cosecant, excuse me, theta. When I see a 2 cosecant theta, I'm thinking about its reciprocal, 2 sine theta. So I'm going to graph where 2 sine theta is, and then I can start to find where the asymptotes are. Anywhere where sine is 0 is where an asymptote is going to be because you can't divide by 0. And then I'll start making my horseshoe prints. So we're going to get to graphing this, 2 pi. Period is just going to be 2 pi because my b value is 1. That's going to be pi over 2, and 3 pi over 2. Don't have any shift up or down, we just have an amplitude of 2. So I'll put 2 right there, and negative 2 down there. And there we go. And sine is going to start at 0. So we'll graph that. We're going to go up to the highest point, back to 0, lowest point, and then back to 0. So there's one sine curve. Now I'm not going to draw that sine curve. I'm just going to use that to find my asymptote. So wherever sine is 0, that's going to be an asymptote. That's going to be an asymptote. And that's going to be an asymptote. We're doing the reciprocal. So if sine is 0, you do the reciprocal of 0, 1 over 0. That's undefined. And then you graph your horseshoes. So this, oh, I don't want green, I want blue. This is going to approach asymptote here. Going to approach the asymptote here. And then down here, same thing. Approaches the asymptote, approaches the asymptote. So there would be your 2 cosecant theta. E, we are looking at a secant. So we think about the reciprocal of secant. Reciprocal of secant is cosine theta minus 1. So that gives us a k value of negative 1. So we'll graph down to negative 2 here. And we'll make this negative 1. And that would make this 1, and this 2. And then this would be 2 pi. And this would be pi. And this would be pi over 2. And our 3 pi over 2. All right. And we're doing a shift down 1, so my x-axis is going to shift down 1. I'm going to kind of go through my intervals there. That's okay. All right. Cosine graph. So cosine graph is going to start at its highest point, go through 0 at pi over 2, then down to its lowest point, back through 0, and then back to its highest point. Now this x-axis, this is, or my -1, that's where my new x-axis is, so that anywhere it hits 0 there, those are going to be where my asymptotes are. And there's my asymptotes right there. And then I can start to graph my horseshoe. So I only graph half the horseshoe here. Here I can graph the full horseshoe. And I can graph the other half of the horseshoe over here. So there would be my secant graph. So secant models a cosine, so we can graph. This is where that cosine would have been, right there. And then we're going to graph those asymptotes and start to graph our horseshoes. But we're not actually graphing the cosine. We're just using those points to find where those asymptotes are and then make those horseshoes. Lastly, cotangent. So cotangent is the reciprocal of tangent, so we kind of graph it the same as tangent. So just a couple things about cotangent here. We got an a of 1. We've got a b of 1/4, which means my period is going to equal 4 pi. And that means then my asymptotes with the cotangent, your asymptotes always start at 0 plus 4 pi n. So every time there's the 4 pi interval, then you'd have another asymptote. So we're only going to 2 pi, so we're going to mark where 2 pi is. And pi would be right here. Pi over 2. And 3 pi over 2. Perfect. Amplitude's 1, so we'll just put a 1, -1, but these are going to go off to infinity anyway. Asymptote is going to be at 0. Now, one full cycle in a cotangent cycle is going to look like this. I'm just going to kind of draw it off to the side. Cotangent cycle is going to look like that. That one cycle is 4 pi in length. So that means that cutting off right here, that would be 2 pi. So we're only going to be able to graph this part of the cycle. That's it. So when I say that this part, that means this part right here. I'm going to graph that first part of the cycle. So heading back to our graph, we can only graph part of the cycle. So I go halfway between where 0 and 2 pi is, and I'm going to mark my amplitude. Graph's coming down the asymptote. It's coming to here, and that's as much as we can graph. It would keep going off in that direction, eventually reaching the asymptote of 4 pi, but we only are going up to 2 pi, so there would be my cotangent. So there's one practice for each type of graph. If you go to 13.8 video help, you'll see more of these secant, cotangent graphs. Tangent is in 13.6, so if you go to the 13.6 video help, cosine is in 13.5, and then sine is in 13.4. So there's where you can find extra help on those types of problems.